Well, good afternoon or good morning. This is our second webinar on QL4POMR Maytax 2021 project, which we started before a few months. And this Maytax project is in collaboration with Dr. Mohammed and Dr. Arnold Kim from Thunder Bay Regional Health Science Center. This project is about solving the dilemma of care design. What is care design? Actually, care design have many interpretations and views. So the question is, which of those interpretations or views is effective and to whom is effective? So this was the dilemma that started with us for long. However, every new breakthrough starts with a dream. So our dream or the idea started when Dr. Lawrence Weed provided the solution, which he envisioned care design to be centered on a problem list. As you know, problem list has many, like it's a list. It could be coming from the lab, from the medication, from different things. So this slide shows that everything is centered on problems list. But Dr. Weed added more by using, you can see here, by using the SOAP node, where the problem list should be presented in a structured way that describe patients' encounter, which is the subjective, and physicians' thoughts as objectives, as well as the assessment to test, followed by the care plan. So I will leave the details of how we tuned Dr. Weed's dream into actionable success. So I will leave the details of the implementation and the details of this Maytax project to Dr. Mohammed. He will be elaborating on this idea. So thank you, Dr. Mohammed.
Thank you. That was an introduction by Dr. Fiaidhi, who's the principal investigator of this Maytax project. And as she mentioned, that this Maytax project is about care design, and the mission to change the way we look at care design actually started by Dr. Lawrence Weed, and we are trying our best actually to envision an implementation to his dream. So the way we done it in the first term of this 5-year project is to build a scaffolding where that scaffolding can describe a system of care that realized Dr. Lawrence Weed's dream. We call that system QL4POMR, and QL, of course, I will describe it. So I will tell you this success story that we done in those 4 months, which is the first term of, and of course, the scaffolding report a great milestones. We call it a great success actually, because the way we seen it, the way we implemented, it goes beyond even our expectations. So we are very happy that we realized many things that Dr. Lawrence Weed designed it upon the problem list, which and coupling everything, which is equal knowledge couplers, based on a new technology that is centered on, around an API called GraphQL. I will tell you lots of things. what GraphQL do as an API, it takes all the silos, all the information, where it will figure out all these problem lists. It could be the claims, the provider, the clinical problems, the prescriptions, and so forth, and put them in one graph. So, and link everything in one graph, one huge graph. Of course, you will need lots of other information to, so POMR take every patient case and create a growing care graph. That growing care graph can go far to describe lots of relations. For example, if you treated 1,000 patients in Alzheimer, you will see how the treatment will go for all of them in one what we call a giant graph. It could be millions and millions of nodes, but this is how, and of course, describing every case in POMR based on SOAP, and that is where we want to realize. GraphQL is central for us. It will connect whatever queries to that giant graph or to any microservice directly. Whatever database, whatever silo, it can connect, and it can build that giant graph. So the thing is, GraphQL is so different. It changed the way software development in so many big giants like Facebook, Netflix, and others. So we are learning from them. I will talk a little bit about, of course, designing whatever mobile, web, other application enterprises was based on REST. This is too different. GraphQL did change the whole map of developing software like care design. So, of course, what is different? The first thing that I want to say, here, when we design care, we design the schema first, not the code, not code first, schema first. How? Because schema will do the interlinks between the different fragments of knowledge. So GraphQL focus on schema design first. But when you say schema first, knowledge differ. When you describe a patient in one description, it could be different from other. A treatment could be different from other. How the different schema can be integrated? That's the magic of GraphQL. It gives you something called resolvers, and resolver will enable you to do all the to accommodate all the variants of description in one big schema. So this schema is flexible, and what we tried in the first vision is to use GraphQL to connect to important healthcare record like FHIR, the interoperable record, and of course we tried also to produce what is called international patient summary, IPS, which is also an HL7 initiative. So we done those, and we were so surprised based on a schema like this. This is a SOAP schema that we have, where we link subjective, objective assessments and plan, and all its variation in one big schema. And that schema, of course, I can use it to link every type of knowledge presented by whatever clinician through what we call Apollo. Apollo is another server which allow you to do federation of, on various sources of knowledge through GraphQL. So I can collect whatever fragmented knowledge from wherever it comes through Apollo, and then I can create my giant graph that I was talking about. Look, this is only a small experiment that shows if I use it, can I describe a patient case based on subjective, objective, and we made a lot of success in describing a lot of patients. And then
every patient can be linked to the others, and we can see the care in certain medical practice clearly, and it will give us a lot of information. Look, what we done in this 4 months is to not only build a POMR based on GraphQL, but we represent the SOAP within it, and we link to HL7 FHIR, and we generated the international patient summary too. Of course, you will tell me, well, international patient summary, it's for plant care. Did you go further? Because if I have if somebody came to a medical practice and say, this is my case, and they have a record, I can generate easily for referral purpose, for other purposes, I can generate the IPS back. But what if somebody came to the emergency department and they do not have that record, and we do not have time? For example, somebody from Alberta came to Ontario, their file is in Alberta. It's not easily to connect the record. So, but they need to be treated. They have a chest pain. They need to respond. So how do you create an IPS for unplanned care? That was another question raised by lots of caregivers, actually, especially from Alberta. We are communicating with them. I will mention them. So actually what we done too, based on our, we connected also with Dr. Arnold Kim from our side, actually, because it's 2 sides. Arnold Kim is developing a very innovative care design system called Aurora. So we, of course, their Aurora is in Scala. So we made a scaffolding also to connect to our system to the Aurora. So that we can talk about it too. Look, when you connect to FHIR, you will need to connect the schema that is for GraphQL or QL4POMR to what we call the resources, the information resources of FHIR, and we done a lot of harmonization in that direction. It's very successful. Look, this is the schema of the IPS, the International Patient Summary, and it shows International Patient Summary is there are required fields like medication, allergies, and problem list, but there are things that can come as a recommended or optional. So that's very flexible summary. You can use it for planned care or unplanned care. So what we done lately, of course, the harmonization between SOAP and IPS and the actual FHIR, it's all done. So we done that one, and believe me, we use little bit more innovative GraphQL called reactive GraphQL. So in order to, because for example, when you ask for a summary, any change in the healthcare should change the summary at the same time. So whenever change here should be done there too. So you need something called reactive. So whenever you change in the record, the summary will be directly changed also. So we build a CRUD. That means create, read, update, delete front end for our platform. And it can connect to FHIR. It can enable physicians to describe their patient cases, even a new one based on SOAP, and save it as FHIR record, as well as to generate the IPS out of it. Look, our work is a huge one, and it's all because the dedication of Dr. Fiaidhi, myself, and our associate Darien Sawyer, which I will talk about him later. So, but we started to become more innovative. What if we want to connect to other healthcare services? Then we need something called backend for front end. So can we add backend for front end so we can connect many other healthcare services to our system? That's what we done. For example, one of the services required by every actually a good healthcare system is to generate for the physician the standard order sets, SOS. So, of course, what been presented to us by Alberta Healthcare is that what if for unplanned care I want to generate what we call it a standing physician order because when somebody have a chest pain, you need to treat them very fast. You need to issue a physician order. So what if I can, from some subjective, without having all the facts, for example, once I say chest pain, I should have an order. So we build that extension based on BFF, and we generated the physician standing order, or we connected. Of course, our standard order set, we took them from Alberta. They give us 43 standard order set for those cases that can happen in emergency departments. So we are very happy to what we done in the background, that BFF, we index them, and once then we search according to the subjective that we have. If somebody have chest pain, then we will link to that physician order, and then this is a kind of result that you will see immediately. It will generate to the physician a standing or saying, well, in that case, this is the things. It will take for him whatever possible, but it will remain the others, which the physician can change. Of course, what is next is a lot of things. We have a lot of targets that we are going for. The most important thing now, our scaffolding become a huge one. So we need to organize our way that we talk to that microservices. So the first thing that we put for us is two things actually: the data layer, which is the first layer that take all the data from whatever sources. You see, now our QL4POMR communicate directly with the server, okay? And that will tangle if you have lots of sources that you are communicating with. You have to bring them to the server, and because you need to have that big schema to generate. But what if you can keep the data in the other servers? How do you communicate? How do you sniff the semantics of that data from the other server? So this is where we need a data layer, and we need a tag layer, and the tag layer will monitor how that tag will be used. For example, if somebody is using an order set, I want to know who used it, why, what cases, things like this. So I need monitoring, so and analytics, so that the data layer and tag layer. So we are adding them to our system. That's how the tag layer and data layer, as you can see, and that's one of the next missions that we will start in our second term. As well as in the second term, we will connect to different backend, and the different backend here should be free, schema free. And this is something where we will use Neo4Java. There are many other things I can talk about, but I will leave the details, technical details, to our associate, Mr. Darien Sawyer, which we appreciate very much, his passion and creativity to follow our ideas and implement most of the things. And thank you so much. I better stop here and let Mr. Darien Sawyer complete.
Hello, I'm Darien Sawyer, and as mentioned, I'm going to be going over the QL4POMR scaffolding that we built up to this point, as well as go over some demos of the different components in our testing environments. So the first component of the scaffolding that we built is GraphQL, which is the query language used in the QL4POMR ecosystem. And through this language, we've been able to implement the SOAP schema, containing the 4 categories for subjective, objective, assessment, and plan, which is the main structure of the schema. And through that structure, we're able to connect any other data types to the SOAP schema, which is the flexibility that we are aiming for using the GraphQL query language. Additionally, using the language, we're able to implement the CRUD functionalities, which is the ability to create, read, update, or delete any data types connected to the SOAP schema using GraphQL resolvers. The next component of the scaffolding is FHIR integration. And FHIR is a more standardized way of representing the data types connected to the SOAP schema, which is necessary for implementing the QL4POMR on a wider scale and integrating some legacy systems. And so what we've done here is we're able to connect the different resources in FHIR, like medication or observation, into the different components of SOAP. As well, with regard to FHIR, we're able to generate what's called an international patient summary. And this summary is generated using what's called a reactive GraphQL. And what this does is it constantly observes all the FHIR resources within a SOAP schema, and whenever they are created, updated, or deleted, it generates a new patient summary based on the resources that are in that schema. And then that patient summary can be used for sign-overs or just relaying information to other physicians. So it's a very important component of the FHIR integration. And the last main scaffolding component that we have at this point is the ability to interact with standing order sets. And these order sets are contained within PDFs and folders. And it's comprised of three components, which is indexing, searching, and updating. So indexing takes in the metadata of these PDFs and creates an index, which helps make the searching more optimized. The searching itself is used using key information and keywords within the SOAP schema. And then the updating takes the results of the search, and it's able to update what's returned and change the order set so that it only contains the information and the orders that the physician might need, removing any other unnecessary information like title pages or blank pages. So these are the main components of the scaffolding, and next I will go over the different components in some demos, starting with the GraphQL component. So the first example I'll go over is how to actually interact with the ecosystem. So we start off with a graph database here, just so you understand how the query is set up. So in a graph database system, you have the collections instead of tables, and you have collections of patients, which are connected to SOAP nodes, which in turn are connected to subjectives, objectives, assessment and plans, and so on. And an example of what those collections look like is something like this, where you have the basic information about the patient, but then other fields could be references to other data types, which would have their own subset of fields. And so GraphQL is the language that we use to traverse this database, and I'll show you an example of that. So here, since we want to just find some information about that patient, we just start off with a query. If we wanted to change some information, then it would be a mutation. And so since we have a query, we want to find a specific patient by their ID. And what's nice about GraphQL is it auto-fills most of the fields for you, makes it easy to pick up. And I'll paste that ID that I copied earlier. And then here we can just use control space, and it'll show you all the different data fields that you can find. So for this specific patient, let's say we want the name, say we want their age, and then we can start going into information within their SOAP nodes. So we want to get the date, some information about the subjective, and if it's a data type that has subfields, then you use the curly brackets here to query those fields within the data type. So subjective, we want to get to patient medical history, which also has some subfields, and say we just want to find the family history of this patient. And then we hit that, and it'll bring up all the information that we asked for. So we got the name, the age, the date, and some family history about that person. And this could be done for as much or as little information as you want. An example query is right here, where you can find all the information connected to that patient very quickly, just like that. So that's how the language is used to query information from the database. But let's say that we want to do a mutation. We want to create a new patient. For that, you would simply use mutation. And in the mutation field, you can hit control space, and again, it'll autofill all the functions that you could use within the system. So for this one, we just want to create a patient very quickly. We just say test, and it's a male. Hit that, and we see that a new patient has been created, and that's the new ID. Going back to the database, and if we refresh this, and we see that it's been added successfully. So that's how you use GraphQL to interact with the QL4POMR ecosystem. So now that you've seen the basic CRUD functionalities of QL4POMR, the first resource that we aim to incorporate were FHIR resources, which is a standard way of representing the medical data types. An example here is a medication resource, which has some basic identifiers and then some standard information for that medication. And using these resources rather than our own custom resources, it creates a more standard version of the system. So incorporating these resources into QL4POMR is as simple as just adding data types to the subjective field here, for example. You could connect it to a medication summary data type, and that medication summary would hold resources for medications. And querying that would be as simple as before, where we have a query here. And you just hit that, and it brings up all the information going from the SOAP node to the subjective to the medication summary, and then grabbing all the medication information held within that data type. Now, the next important aspect is maintaining the ability to create, update, or delete these resources. And so I'll go through an example of updating medication information here. The mutation query looks like this, where you identify it by its ID, and we want to change the status and div of this medication specifically. So in that here, we have those fields just saying hello, so we know what we're looking at and what's supposed to change. Make sure it's the same ID here. And if we run the update, let's see if it changed. Yeah, we see that this has changed. So now we've incorporated the CRUD functionality into the resources themselves. And the last step of incorporating FHIR into the system is generating a patient summary. Using these resources here, being able to dynamically generate a summary if information here was changed, if it was deleted, if it was created. And so an example of that summary would be here, if we get rid of the information that's already there, just to show you how it works. Starting with an empty patient summary, if we run that mutation again, it'll see that it'll constantly check if that medication is being updated or changed or deleted. And if it has, then it will update the field here. So you see I took that out earlier and it was added back. The fields this was changed and this was changed. And so this is a scaffolding for generating a patient summary. But moving forward, what we're doing is expanding the scope of the reactive system so that it looks at all the resources in the SOAP node. And so all these entries will be updated dynamically whenever an entry in the SOAP node is changed or deleted or created. So the last functionality that I'll go over is how QL4POMR interacts with standing order sets. And this is done through three functions. The first one is indexing, taking a folder of standing orders here as PDFs and indexing them through their metadata. And that takes the information like a title, the author, the subject, and indexes them in their own data structures so that it's easier to search them. Because the next function is searching, taking that information from the index and as well as information from the subjective node, and finding the proper standing order set that is required for that subjective information. And then finally, it is updating the standing order set because the information in the PDFs might be irrelevant, like title pages or blank pages. So we want to update the order set so that it only returns the fields that the physician might need. So I have a test script written here to go through each of these functions one by one. First by indexing them based on the metadata, and then searching. Here we're searching from the subjective entry of presenting complaint in the database. That looks like this, where the presenting complaint has keywords for chest pain here. So it should take that information and ignore everything else in the subjective node, just returning the keywords chest pain to search. And we are using those keywords to search the index by the title field. So it'll return the standing order set that has the title best matching to the keywords in the presenting complaint. And then from there we can update it based on the information found within that order set. So running that test here, you see how it indexes the information here, taking the file name, the author, the creator, producer, subject, title, number of pages, information like that, and creating an index for easy searching. From the search, it went to the presenting complaint and got the keywords chest pain. Searching by title, it returned the proper file, which is the emergency department standing order for chest pain. And from here is where we can change this standing order based on the information that we need. So these are the 6 standing orders, or the order sets that are in that file. And say the only thing that we want to return is diagnostic imaging. So we say 3, and it'll generate this new file here. We click on it. We'll see that it's just one page with diagnostic imaging at the top and other information in that page, which we're not able to remove. But it did succeed in isolating only the information that we want while removing unnecessary information like the title page or other information. Like this is the original file, and you see it has the title page which we don't need, some orders that we don't care about at this point, did take this page that had diagnostic imaging and just removed everything else. And so that's how it's able to find proper standing order sets based on a silo of PDFs, index them properly, search through them, and then return only the information that the physician might need based entirely on what information is in the subjective node. And so that is all the demos from me. Thank you all for listening, and I look forward to presenting the system again when it has more functionality, as well as how the functions presented here have become more robust over time. So again, thank you for listening.